Imagine a device so small yet so powerful, it promises to challenge the way we think about energy. A system that doesn't rely on fuel, conventional grids, or even solar panels. That's exactly what Maxwell Chikumbutso demonstrated with his RF generator, a device that turns invisible waves into usable electricity. Now, imagine recreating that at home. Not as a gimmick, not as a hoax, but as a proof of concept for personal energy independence. Today, we're diving into how you could approach building your own RF generator, inspired by Chikumbutso's pioneering design, and exploring the science that makes it work. Before we start, it's important to note, we're not claiming to produce infinite energy or defy physics. This is about experimenting, learning, and understanding energy differently. It's about taking principles that have traditionally only existed in laboratories and making them tangible in a small-scale, personal environment. The core principle of the RF generator is simple in concept, but precise in execution. It captures radio frequency energy from the environment and converts it into usable electricity. In urban areas, the air is already saturated with signals, from Wi-Fi and cellular towers to radio broadcasts. The challenge is harvesting that energy efficiently and safely. Components are critical. A small antenna acts as the gateway for ambient RF signals and specialized circuitry. Resonators, capacitors, and high-frequency diodes transform these waves into a current you can store in a battery or capacitor bank. Even minor adjustments in the placement of the antenna or tuning of the circuit can dramatically impact the output. This is where Chikumbutso's ingenuity comes into play. He optimized the system to work with minimal input, ensuring that the energy captured isn't wasted. In practical terms, it means a small tabletop generator could potentially power LED lights, charge small devices, or run sensors, all while drawing from energy that would otherwise go unnoticed. Safety is paramount. RF energy at ambient levels is generally harmless, but mishandling circuitry, improper grounding, or connecting the wrong components could be dangerous. For anyone attempting a DIY approach, attention to detail and disciplined experimentation is non-negotiable. The beauty of a project like this isn't just the device itself, it's what it represents, a mindset shift. It encourages you to think about energy as something you can interact with directly, not something you passively consume. It's about curiosity, experimentation, and challenging the idea that access to electricity is dependent on infrastructure. And the potential implications are huge. Imagine small communities deploying dozens of these small RF generators. Suddenly, the cost of basic energy needs drops. People gain independence from fragile grids. Education, healthcare, and small businesses gain access to power that would otherwise be inconsistent or expensive. But here's the part most people overlook. Chikumbutso's generator isn't just about energy, it's about inspiration. It demonstrates that innovation doesn't need multi-million-dollar labs. It starts with understanding your environment, asking questions, experimenting responsibly, and refusing to accept limits that others impose. And while replicating this device at home is just the beginning, the journey itself teaches lessons about physics, electronics, and creative problem-solving that textbooks often overlook. Every connection, every capacitor, every diode becomes a classroom for experimentation and a window into what's possible when ingenuity meets necessity. At this point, you might be asking, what are the practical steps for building your own RF generator? That's exactly where we'll pick up next, diving into component selection, circuit assembly, and safety tips to explore the principles firsthand without risking harm. First, let's talk components. At the heart of the RF generator is the antenna. It doesn't need to be large. A simple wire or loop can capture ambient radio signals. But placement matters. High locations near windows or facing known signal sources can dramatically increase reception. Think of it as tuning your device into the invisible currents flowing through the air all around you. Next, the circuitry. The signal captured by the antenna is tiny and inconsistent, so it needs to be amplified and rectified. High-frequency diodes and capacitors form the rectifier bridge, converting AC signals into DC that can be stored in a battery or capacitor bank. Precision is key. Wrong components or poor soldering can drastically reduce efficiency, or worse, damage the system. Then there's energy storage. While the RF waves themselves are weak, storing the energy in a capacitor or a rechargeable battery lets you use it in short bursts. This could power LEDs, small fans, sensors, or even charge mobile devices slowly over time. The effect isn't instantaneous, but it's a glimpse into what's possible when you tap into overlooked energy sources. Chikumbutso's genius lies not just in capturing energy, but in making it usable. He tuned the system to operate under low input, allowing even small environmental signals to produce measurable output. In essence, it's a bridge between invisible waves and tangible power. Experimentation is where the real magic happens. Every setup will behave differently depending on location, ambient signals, and even weather. The more you adjust the antenna, test circuit configurations, and measure outputs, the more you begin to understand the subtle dance of energy around you. And this is where the learning curve accelerates. You start noticing patterns: which frequencies carry the most energy, how wire lengths affect resonance, how different diodes respond to weak currents. It's like decoding a hidden language, the language of energy itself. For those aiming to push it further, Maxwell's approach inspires a mindset: iterate quickly, measure meticulously, fail safely. Every small improvement compounds. One day, a simple LED powered from ambient RF might become a small sensor network, or a device that provides emergency lighting for a rural home. But the most valuable lesson isn't technical. It's philosophical. Chikumbutso's RF device isn't just a machine, it's a call to action. It challenges the notion that energy is something you buy or depend on. It says, look around, notice what's invisible, and turn it into something useful. The real power comes from realizing that your environment is full of untapped resources, waiting for someone curious enough to explore. Every step in building a DIY RF generator is also a step toward rethinking how we interact with energy, innovation, and problem-solving itself. And this is just the beginning. Because once you grasp the principles and start experimenting, the possibilities expand. Modular devices, energy networks, small-scale off-grid solutions, even community-level innovations inspired by what started as a simple experiment on a workbench. Next, we'll explore how to safely assemble your RF generator, what tools and components are essential, and the common pitfalls to avoid for anyone attempting this at home. Now, let's move into assembly and safety, because a DIY RF generator isn't just about connecting wires, it's about precision, awareness, and understanding what each component does. Start with your antenna. Even a simple copper wire can work, but its length and orientation matter. Horizontal, vertical, or loop configurations each capture different frequencies. For beginners, a small loop antenna is ideal. It's compact, easy to mount, and effective for capturing ambient RF signals from Wi-Fi routers, cell towers, or even radio broadcasts. Next is the rectifier circuit. This is where AC signals are converted into DC. High-frequency diodes, like Schottky diodes, paired with capacitors, store and smooth the electrical pulses. Each connection needs to be tight, clean, and well soldered. Loose connections reduce output dramatically. Here, patience matters more than speed. One misstep can ruin hours of setup. The energy storage unit is the next critical step. Small rechargeable batteries or capacitor banks allow you to accumulate energy over time. This is what transforms fleeting RF waves into something usable. At this stage, measuring voltage output frequently is essential. It's a slow accumulation at first, but it's also proof that ambient energy is everywhere, waiting to be harnessed. Safety cannot be overstated. Even low-level RF energy can interfere with electronics, and improper connections risk short circuits. Always use insulated tools, double-check polarities, and never connect the system to high-voltage devices. Work methodically, document each step, and adjust gradually. Once the circuit is connected and the storage is in place, it's time for testing. Place your antenna near a known signal source, a Wi-Fi router, a radio tower direction, or even a cell phone transmitting nearby. You'll start to notice small fluctuations on a voltmeter. That's your first sign. The invisible energy in your environment is being captured. From here, it becomes a game of refinement. Adjust the antenna position, tweak the capacitor size, or experiment with diode configurations. Each minor change alters efficiency. With each successful tweak, your device grows more responsive, more capable of powering LEDs, small fans, or sensors. And here's the hidden beauty. Even if the generator produces only a fraction of what you expect, the knowledge gained is enormous. You're learning RF resonance, power conversion, energy storage, and circuit behavior, principles that underpin everything from smartphones to satellites. Maxwell Chikumbutso's RF device is not magic. It's methodical experimentation taken to its extreme. The genius is in optimizing what's already around you, in seeing potential in the signals we ignore daily, and in the willingness to iterate and improve continuously. Once your first prototype is working, even minimally, the possibilities expand. Small-scale home applications like lighting a desk lamp, charging a phone overnight, or running sensors in an off-grid setup are just the start. From there, you can explore modular networks, scaled-up energy collection, and even collaborations within a community of innovators. And this is where the real lesson begins. The generator itself is a tool, but the mindset it teaches is far more powerful. Observing, experimenting, failing safely, and improving relentlessly. That's what drives real innovation. Next, we'll dive deeper into scaling the DIY RF generator, turning a small personal experiment into a practical system that could power multiple devices, and exploring creative adaptations inspired by Maxwell's original design. Scaling your DIY RF generator begins with networking multiple units. One small antenna and circuit can power tiny devices, but connecting several in parallel or series increases the total energy captured. Imagine a small cluster of generators on a rooftop or balcony, each tuned slightly differently to harvest overlapping frequencies. The combined output becomes meaningful, capable of running multiple LEDs, charging batteries faster, or powering low-wattage electronics continuously. Placement is everything. Higher elevations reduce obstacles and interference, and spacing antennas slightly apart ensures that signals don't cancel each other out. In urban environments, positioning near strong Wi-Fi routers or cell towers can drastically improve performance. In rural areas, capturing long-range broadcast signals or using low-frequency bands can yield surprising results. Experimentation at this stage isn't just encouraged, it's essential. Adjusting antenna shapes, testing different capacitors, or swapping diodes allows you to observe how minute changes affect output. Maxwell's breakthrough wasn't just his circuitry, it was the persistent trial and error methodology, combined with careful observation and adaptation. Once you have a multi-unit setup, consider energy storage strategies. Individual capacitors can store small bursts, but connecting them to larger battery banks lets you accumulate enough power for practical use. Lithium-ion packs or even repurposed laptop batteries work well, as long as you manage charging carefully. Safety circuits, voltage regulators, and fuses prevent damage to the batteries or connected devices. Now comes the fun part, testing real applications. A single LED or sensor is impressive, but once multiple devices run off your DIY network, the impact becomes tangible. Think desk lighting that's independent of your home grid, phone charging during outages, or small fans cooling your workspace, all powered by energy that otherwise flows unnoticed through the air. This is where the principle of invisible energy made tangible becomes clear. Maxwell's genius lies not in inventing something mystical, but in making ambient energy usable, understandable, and scalable. Every experiment, every prototype, is a step toward independence, not just personal, but potentially communal. And the mindset shift is equally important. Building this device teaches patience, attention to detail, iterative problem-solving, and deep observation. You start noticing how RF signals fluctuate with weather, time of day, and urban activity. You learn to see energy as a resource to interact with, rather than a commodity to consume. Once your prototype is reliably powering small devices, the possibilities expand further. Community-level projects can deploy multiple units to power small schools, local clinics, or emergency lighting in remote villages. Maxwell's work shows that scaling isn't only about money or infrastructure. It's about creativity, resourcefulness, and applying fundamental principles in innovative ways. At this point, what starts as a simple DIY experiment transforms into a philosophical and practical lesson in energy independence. Every connection, every capacitor, every diode becomes a symbol of curiosity and persistence. And with every small success, you're not just replicating a device, you're stepping into the same mindset that allowed Maxwell Chikumbutso to push boundaries, challenge assumptions, and inspire a generation of innovators. Next, we'll explore advanced adaptations, including how to fine-tune the RF capture for maximum efficiency, integrate sensors or microcontrollers, and potentially create a fully self-sufficient off-grid setup inspired by Maxwell's concepts. Advanced adaptations begin with signal tuning. Not all RF frequencies are equal. Some carry more energy, others are easier to capture. Using simple variable capacitors or adjustable coil loops, you can tune in to specific bands, maximizing the energy captured from Wi-Fi, radio, or cellular signals. Each adjustment teaches a new lesson about resonance, wave behavior, and the hidden energy surrounding us every day. Next, integrating microcontrollers and sensors opens a world of automation. A small Arduino or Raspberry Pi can monitor voltage output, control storage banks, or even switch between circuits, depending on signal strength. Suddenly, your generator is no longer passive. It's smart, responding in real time to fluctuations in ambient energy, making it more reliable and efficient. Another level of adaptation is environmental optimization. Placement near conductive surfaces, reflective walls, or rooftops can amplify signals. Conversely, insulating from interference in urban environments ensures cleaner energy capture. Small adjustments, repeated trials, and careful observation mirror the same iterative principles Maxwell applied on a larger scale. Once you combine multiple generators, tuning, and microcontrollers, you can achieve continuous small-scale power output. Imagine a single off-grid workstation running lights, sensors, and communication devices purely from RF energy in the environment. For many, it's not enough to fully replace a grid, but for experimentation, emergency power, or small-scale independence, it's revolutionary. And here's the hidden lesson. This isn't just about building a device. It's about retraining your perception of energy. You begin to notice signals, waves, and currents that were always present but ignored. You start to think in terms of opportunity and scarcity, of solutions in what others consider limitations. This mindset, curious, resilient, inventive, is the core of Maxwell Chikumbutso's legacy. Scaling further, communities can experiment collectively. Multiple households or makerspaces could deploy small generators networked together, sharing energy and insights. What started as a personal project becomes a collaborative learning ecosystem, mirroring the way African innovators adapt, iterate, and improve under resource constraints. Finally, there's the philosophical dimension. This generator, simple as it is, symbolizes empowerment. It demonstrates that energy doesn't have to be purchased in bulk from monopolies. That innovation isn't confined to labs with million-dollar budgets. That curiosity, resourcefulness, and iterative experimentation can spark real, tangible change, even in small-scale projects. And as you experiment, tweak, and optimize, you're not just creating electricity, you're creating understanding. Understanding of physics, circuits, environmental signals, and perhaps most importantly, the potential of human ingenuity when necessity meets creativity. Next, we'll dive into practical examples of applications, showing how small RF generators can power real devices, from emergency lights to communication tools, and how these experiments can inspire larger innovations in energy independence. And that's the power of curiosity combined with ingenuity. What started as a small experiment, tapping into invisible waves with a few wires, capacitors, and diodes, has grown into a window into the future of energy independence. Maxwell Chikumbutso's work isn't just about one device or one invention. It's about teaching us that innovation often starts where others see limitations, that small-scale experimentation can spark ideas with global impact, and that resourcefulness can redefine what's possible. By building, testing, and refining even a simple RF generator, you're not just generating electricity, you're generating understanding, creativity, and a mindset for solving problems that others overlook. So whether it's powering a single LED, charging a small device, or inspiring an entire community to think differently about energy, the lesson is clear. The future belongs to those willing to explore, experiment, and refuse to accept the boundaries set by convention. And that's why, after everything I've seen, I can finally say, the story of Maxwell Chikumbutso isn't about being right or wrong. It's about possibility realized, curiosity unleashed, and a spark that could light the way for millions. Because innovation doesn't wait for permission, it waits for the brave.